This is explanation of page 12, which is your quiz review. You only need to look at this if you need like further explanation of the answers. If you just want to check the answer key, it's on Canvas. Keep in mind the entire time you are doing this exam, you want to be, or this practice, you want to be referring to a completed unit circle. And so you'll see that I have one copy and pasted on here. You'll be filling one out for your test, and then you'll use the one you fill out. So you have to continue to work on memorizing the unit circle. So here's what we know about the unit circle. I have a completed one at the top here. And I want to find the cosine of 60 degrees. Well, cosine of 60 degrees is something that's in quadrant 1, so I can just use the unit circle directly. So what I know about cosine is x values. So what I'm really looking for is x at 60 degrees. So I'll go to the 60-degree angle on my unit circle, which is right here, and I'll look at the x value. So my x value at 60 degrees is 1/2. So cosine of 60 degrees is also 1/2. This one's a little bit trickier because 5 pi over 4 is not an angle that I have in quadrant 1. I have pi over 6, pi over 4, and pi over 3. So this is not an angle in quadrant 1. I have to think about what quadrant it is in. So 5/4 is the same thing as 1 and 1/4 pi, which is the same thing as 1.25 pi. And I know that pi over 2 is like 0.5 pi, and this is like 1 pi, and 3 over 2 is like 1.5 pi, and 2 pi is 2 pi. So 1.25 is somewhere between 1 and 1.5. So this angle is somewhere in quadrant 3. And I know that cotangent pairs with tangent. So what I know about tangent in quadrant 3, all students take, this is T quadrant, tangent theta is positive, which means my final answer for this one's going to be positive. I also need to find the reference angle, which is actually really easy when you're given one like 5 pi over 4. There's only one angle in quadrant 1 that I know of, right? So the only angles I know in quadrant 1 are pi over 6, pi over 4, and pi over 3. Well, there's only one of them that has a denominator of 4. So my reference angle is going to be pi over 4. And what that means is I can refer to pi over 4's coordinates when I'm answering this question. All right, so there are my coordinates. If I want to find the tangent of pi over 4, I do y divided by x, which is already worked out for you. Maybe you memorized the unit circle and you have them written in green like I do in the top, or y divided by x. These are the same numbers. Root 2 divided by root 2, root 2 divided by root 2. When you take a number divided by itself, that always equals 1. So the tangent here at pi over 4 is 1. What that means about cotangent of pi over 4, what that means about tangent of 5 pi over 4 is that the tangent of 5 pi over 4 is the same thing. Tangent of 5 pi over 4 is also 1. Sometimes I'd add a negative to this, but because it's in quadrant 3, I know that it's positive. Well, I want the cotangent, which means I need to flip the fraction. This isn't a fraction right now, so I can make it 1 by putting it over 1, and then I can flip it, and it's still just 1 over 1. So if I flip the fraction, cotangent of 5 pi over 4 is still just 1. So the answer to this one is 1. A little bit more work than the previous one. Okay, secant of 3 pi over 2. Well, 3 pi over 2 is not in a quadrant. 3 pi over 2 is a coordinate point. So since it's not in a quadrant, I can't decide if cosine's positive or negative there. This is a special case. It's a corner point. Corner points don't have reference angles. I just need to look at the unit circle. Secant goes with cosine. So I'm going to find the cosine of 3 pi over 2. Remember, cosine is the x values. So I'm going to go to 3 pi over 2 and look at the x value. The cosine of 3 pi over 2 is 0. Well, to do secant, I need to flip the fraction. So I need to make this a fraction and then flip it. And when I flip that fraction, I get 1 over 0, which is an error. You can't divide by 0. So the secant of 3 pi over 2 does not exist. That one's a little tricky. All right, 5 pi over 3. Well, let's think about what we know about 5 pi over 3. That's 1 and 2/3, which is 1.66667. So that's somewhere between 1.5 and 2, which means this is going to be in quadrant 4. And cosecant goes with sine. So what I know about sine in quadrant 4 is that it's negative. The only thing positive in quadrant 4 is cosine. So I know that my final answer here is going to be negative. I also need to find my reference angle. Well, between the 3 angles that I have in quadrant 1, the only one with a denominator of 3 is pi over 3. So I know I'm going to refer to the coordinate point at pi over 3 to get my answer here. So cosecant pairs with sine, so the sine at pi over 3 is the y value at pi over 3, which is root 3 over 2. And what that means is that the cosecant of pi over, not cosecant. What that means is that the sine of 5 pi over 3 is the same. It's root 3 over 2. But because 5 pi over 3 is in quadrant 4, I add the negative. Quadrant 1, everything's positive, which is why sine pi over 3 is positive root 3 over 2. But in quadrant 4, the y values are negative, so I have to add a negative sign to that. Now, if I want to find the cosecant of 5 pi over 3, I'm just going to flip the fraction of the sine of 5 pi over 3. So I'll put the 2 in the top and then root 3 in the bottom. And then I'll have to rationalize that to get the root out of the bottom. So I end up with negative 2 root 3 over 3. Tangent of 150. Well, 150 is somewhere between 90 and 180. So this is a quadrant 2 angle. And what I know about tangent in quadrant 2 is that it's negative, because sine is positive in quadrant 2, but everything else is negative. That means my final answer here is going to be negative. I need to find my reference angle here. So if I draw something in quadrant 2 and I use the x-axis to create the reference triangle, I want this angle, and I know that that's 150. So together, this green angle plus what I know, this green angle 150, what I know, plus what I want to know, together makes a half circle, which is 180 degrees. The quadrant 2 rule says that my reference angle plus my standard angle equals 180. And reference angles are small, standard angles are big, so I have a standard angle. And if I subtract 180 from both sides, I get my reference angle is 30 degrees. So I'm going to refer to 30 degrees when I do this one. The tangent at 30 degrees I have already worked out, but if you didn't have it worked out, like you didn't memorize it, it's y divided by x. So I would do 1/2, keep y, change divide to multiply, flip x. So I would flip this. And what happens when you do this math is the 2's cancel out, and we get 1 over root 3. And when we rationalize that, we get root 3 over 3, which you can see I have written here. So you can choose to memorize the tangent at 30, or you can work it out every time. The tangent is y divided by x. So the tangent at 30 degrees is root 3 over 3. So that means the tangent of 150 degrees is also root 3 over 3. It's just that because it's in quadrant 2, the tangent's going to be negative there. So I'll add a negative to my final answer. Finally, we have sine of 300. Well, I know 300 is somewhere between 270 and 360. So this angle is somewhere in quadrant 4. And I know that cosine is positive in quadrant 4, but sine is negative. So my final answer to this one's going to be negative. I just need to figure out what the reference angle is. So you can draw a picture where this is what I'm trying to figure out, and this is 300. So together, what I'm trying to figure out plus what I know equals a full circle. And so if I divide both sides if I subtract 300 from both sides, I get that my reference angle is 60 degrees. So I want to refer to the 60-degree angle when I do this one. And since I'm working with sine, I want to look at the y value. So at 60 degrees, the y value is √3 over 2. The sine of 300 is the same thing. It's the same triangle, it's just in a different quadrant. So it's still √3 over 2, but because we're in quadrant 4 now, quadrant 4 is below the x-axis and the y values are negative. Sine is negative in quadrant 4, so I add a negative to my answer. The next section here is solving equations. Still, I need to use a completed unit circle for this, so I'm just using the one that I have here. You're going to have to complete the unit circle for your quiz. So for the first thing I want to do here is I want to get the trig function by itself. So I would divide out this 2. And I get that the cosine of theta equals negative √3 over 2. Well, the fact that this is negative means that I'm going to use, all students take calculus, to find where cosine is negative. Cosine is positive in A and C, so it's negative in 2 and 3. So eventually, I'm going to use quadrants 2 and 3 rules to find my cosine. But before I can do that, I need to find my reference angle. To find my reference angle, I want to find where x, because cosine is x, equals √3 over 2. I don't know where it's negative √3 over 2. I only have quadrant 1, which is where everything's positive. So I have to focus in on what I know. The x value is √3 over 2 right here. And in degrees, that's at 30 degrees, which means my reference angle is 30 degrees. Now I need to apply that reference angle to quadrants 2 and 3. You can draw a picture in quadrant 2. Draw your reference triangle. This part here is 30. You want the big part, and together that makes 180. Or you can use the rules that together they equal 180. Reference is the small angle. Standard is the big angle. We have the acute one, so we have the reference. And to get s by itself, I would subtract 130 from both sides, which is why my first answer is 150 degrees. In quadrant 3, you can draw a picture if you want. This is what we know, it's 30, but what we want is 180 plus the 30. So the rule in this quadrant is r plus 180 equals s. Well, my r is 30. So I'm going to do 30 plus 180, which is 210 degrees for my second answer. All right, if I were to get the trig function alone here, I would subtract 3 and then divide by 15. So I would end up with 0 over 15, which is 0. Tangent of 0, if you look up at my green tangents, is a corner point. Corner points don't have reference angles. So I'm not going to find r. I can't put these in quadrants because a corner point isn't in a quadrant. So I just need to look at the unit circle for tan being 0. I see that here and here. I have it memorized. If you don't have it memorized, you got to do y divided by x. Well, 0 divided by 1 and 0 divided by -1 are both 0. So this is the 2 places that tangent is 0. And if I'm in degree mode, that's 0 and 360, which is the same angle. And that's 180 degrees. So remember, corner points, you don't have to do as much work because there's no reference angle. You're just using the completed unit circle. Okay, for the next one, I've got cosecant theta equals -2, but I need to make this a sine. So I'm going to flip that, but I end up with something that I have to rationalize. So I get sine of theta equals negative, because there's a negative sign, √2 over 2. And since there's a negative sign, I'm going to apply this to where sine is negative. Sine is positive in 1 and 2, so it's negative in 2 and 3. So eventually, 3 and 4. So eventually I'm going to use the 3 and 4 rules to solve here for my triangle. But before I do that, I need to find my reference angle, which is something that's in quadrant 1. So I want to figure out where is the y value, because sine is y, root 2 over 2. I don't have any negatives in quadrant 1, so I'm just focusing in on the number. And the y value is root 2 over 2 at 45 degrees. So the reference angle is 45 degrees. We already made a Q2 triangle over there in number 7, so I already worked out that the rule is r plus s equals 180 together, right? But I have 45. So what I'm doing is 180 minus 45. I can't do 0 minus 5, so I'm going to cross off the 8 and change it to a 7 and make this a 10. 10 minus 5 is 5. 7 minus 4 is 3. 1 minus 0 is 1. So this answer is 135 degrees. I don't have a picture worked out for Q4, so I'll draw one of those. Here's my angle in quadrant 4. This is 45 degrees. I want this. So together, that's a full circle. So R plus S is 360. And I know that my R is 45. So ultimately, I'm doing 360 minus 45 to get the S. I can't do 0 minus 5, so I'm going to borrow from this 6 and make it a 5 and change the 0 to a 10. 10 minus 5 is 5. 5 minus 4 is 1, and 3 minus 0 is 3. So the second answer here is 315. Sorry, I'm kind of squeezing that in, but 315. All of these were in degree mode, so all of my references were degrees. 30 degrees, my answer was in degrees, 45 degrees. The second set of directions here says that we want to do 0 to 2 pi. So now I'm going to use the radians. Pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, 2 pi, when I'm solving these. First thing I want to do is isolate the trig function. So for this one, I'm going to subtract 4, and then I'm going to divide by 6. So I get 3 over 6, which is positive 1/2. And since that's a positive number, if I run and all students take Calc, sine is positive in 1 and 4. So eventually I'm going to apply this to 1 and 4. I need to find my reference angle, and since I'm working with sine, I want to find where the y value is 1/2. So I'm looking at my coordinate, or my quadrant 1, and here's y being 1/2. So my reference angle is not 30 degrees, it's radians, so it's going to be pi over 6. I chose that my quadrants were going to be quadrants 1 and 2. In quadrant 1, the reference is the same as the standard. So if the reference is pi over 6, the standard is pi over 6. That's pretty straightforward. In quadrant 2, the two angles together create a half circle, which means they make an 180-degree angle. But in radians, 180 degrees is pi. So I have the small angle. I have the pi over 6 part. And if I want to get s alone, ultimately I'm taking pi and subtracting pi over 6. But to add and subtract fractions, you need common denominators. So this bottom has to have a 6. And if I put a 6 on the bottom, I have to put a 6 on the top too. So I'm doing 6 minus 1, which is 5 pi, and then we keep the denominator the same. So the answer in quadrant 2 would be 5 pi over 6. For this next one, if I want to get cotangent alone, I would divide by root 3, and then I would change it to tangent by flipping that fraction. So it would be root 3 over negative 1, which is really just negative root 3. And the fact that it's got this negative sign means that I'm looking for when tangent is negative. Well, tangent's positive in 1 and 3, so my answers are going to be in 2 and 4. I need to find my reference angle, and tangent is a tough one to find the reference angle for because it's not a coordinate point. You have to work out tangent. So you can see above, I memorized the tangents and I wrote them out. So tangent is root 3 at 60 degrees, you can see up there, which is pi over 3. If you don't have it worked out, you've got to do, or memorize, you have to do y divided by x for all of these where you're dividing fractions. So it's just helpful to memorize it. Tangent is square root of 3 at pi over 3. So my reference is pi over 3. I want to apply that to quadrants 2, 4. In quadrant 2, I know the two angles added together equals a half circle, or pi. And so I am going to do pi minus pi over 3 to get s alone here. And if I put a 3 in the bottom, I have to put a 3 in the top. So 3 minus 1 is 2 pi over 3 for my first answer. That does not look like 2 pi over 3. Let me fix that. 2 pi over 3. For quadrant 4, together the two angles make a full circle. So r and s equal 2 pi instead. So I have pi over 3 here. And I would be subtracting 2 pi minus pi over 3. Well, I need a common denominator of 3, and if I put a 3 in the bottom, I have to put a 3 in the top, which actually makes the top 3 times 2, so I have 6 pi minus 1 pi. So 6 minus 1 is 5 pi, and then I keep the over 3. All right, last one. If I get the secant alone, I'm subtracting 8, so I have secant theta equals -1. Because it's a reciprocal function, I'm eventually going to need to flip it, so I'm just putting a 1 in the bottom. Secant changes to cosine, and if I flip that, it still simplifies to -1. -1 is a corner point, so I'm not going to have a reference angle. Nowhere in quadrant 1 is x -1, so there's no reference angle. So really, I'm just looking at the edges to find where the x value is -1, and that happens here. The x value is -1 at this place, and since I'm using radian mode, that's just at pi. So just remember, if it ends up on a corner, you're just using the circle to find the answer, and you're not finding quadrants. Need more practice? There is more practice on page 13 and 14. I don't have a video for 13 and 14, but I do have the key on Canvas.